All right. So today I'm going to talk about the plow and the cow, two of Aldo's tools, and hopefully you'll understand what I'm talking about when I say those and what he was talking about and how important they are for habitat management. But before I do that, I want to give you a little bit of context. So what you're looking at right here is one of the first maps that was drawn of the New World. This to me is pretty incredible to look at because it's relatively accurate considering in the 1700s when this thing was drawn what they had available to them to draw that. It was just pretty incredible to think about. But I wanted to draw your attention to this word right here, and I know you can't see it right now, but uh, if you zoom in on it, it's grande savane. And you know if you don't know what that means, that literally interprets to grand or a large savanna, grand savanna. And you remember from last time when I was talking about woodlands that savannas are very similar in structure to a woodland, although the savanna is generally sparse trees with a grassland or herbaceous dominated understory. So I realized that I didn't talk about the difference between a herbaceous plant and a woody plant. It is not lignin. That is what most people immediately say is, oh, lignous plants are woody. No, that's not what that's not the case. So if you can have a perennial herbaceous plant and a perennial uh, woody plant that have equal amounts of lignin in it. Okay, so that is not the distinguishing factor. What it does distinguish it is whether or not it grows buds on the same tissue year after year if it's perennial. Okay, so if you have a perennial uh, woody plant, it grows buds on the same tissue year after year. And think about a tree, right? The tree doesn't die back down to the ground every year and then grow a new tree, in the next spring. So that's pretty obvious. But something like pokeweed, if you don't know what that is, look it up. You probably see it all around campus. I certainly do, and I may not know what that is. So if you don't, look it up. But pokeweed is a good example of a perennial herbaceous plant. And that pokeweed dies back down to the root system every year and then grows a new above ground structure that it produces buds and flowers and fruits on every year after year. So that's the difference between herbaceous and woody. So when you have herbaceous plants, grasses, for instance, is probably what you all think about, but grasses and forbs that are herbaceous dominate the understory vegetation in savannas. All right, so woodlands, it could be, there could be a lot of herbaceous plants in the understory, but it's often dominated by woody plants. We still get similar structure, and a lot of the same wildlife species use them, but pretty important for you to understand those differences. So when I think about a savanna, I normally think about something like this. I'm not sure what you think about, but we have longleaf savanna in this state. There's not that much of it left, but we're actively trying to restore it across the state, and it's particularly uh, it has been particularly successful in Florida in comparison to some of the other southeastern states. But yeah, we're still working towards those efforts. What I wanted to impress upon you to give you context is if you actually look, I tried to map out to the best of my ability, and this isn't perfect, but hopefully you can see the outline that I have here of what the early cartographers called Grand Savannah. Look at basically the entire eastern United States, with the exception of the mountains and the Mississippi River alluvial valley right here. Basically, all of it was listed as Grand Savannah. Now, there are some notable exceptions in here where they didn't mark, like right here, there's a grassland. And then, of course, this is all Great Plains over here, so that was grassland. So they left those out. They didn't even mark the Black Belt Prairie right here. But my point is, look at how much of that. Think about how much of that is actually savanna now. It's almost none of it. So we have undergone dramatic land uses. So the question is, historically, why was all that grand savanna or large savanna? And this map probably will help a lot. So this map right here is just showing you the lightning intensity, or actually the lightning intensity looks just like this, and this is showing you the mean fire return interval. So really red, like Florida, means that there's a really quick, that's less than 2 year fire return interval on average across the state. Look at Florida is less than 2 on most of the state, and between 2 to 4 just out here in the Panhandle, right? The entire southeast, but if you remember that map I just showed you, basically everything in red or orange was in savanna. So seems pretty obvious automatically that fire was a critical component to managing that savanna structure. And you're right, if you connected that. Another thing I wanted to show you is a lot of our wildlife species are very tightly coupled to that type of structure. I've got a northern bobwhite here because they have a ton of data on this, but you can see the range of the northern bobwhite. Notice in Florida, it's pretty much all of it until you get down here in the very southern part in the Everglades. But all through the Great Plains, bobwhite very tightly coupled to that savanna structure and to fire. And that turns out to be one of the main management tools that we would use to manage for quail. So why are they so tightly coupled to the structure? So here's the understory in a savanna that I wanted to show you is pretty important for you to understand. One, this is a native warm season grasses. Generally, most of our native warm season grasses that are perennial have this growth structure like you're seeing right here. So we have this clumping structure. That's what we call that. It's a clump grass. So basically, all of the grass is originating from the same base, and it kind of comes up and fans out at the top. Notice there's a whole bunch of interstitial space between the grasses right here. And this is a native forb. It's called sumpweed. And you can see on this plant right here, this sumpweed kind of grows up. It self prunes its leaves. Most of our native forbs do this. And then we kind of have a canopy of leaves. You can think for a quail, this is still a canopy, just like a forest canopy is to us, right? It doesn't have to be that tall, but the quail needs this interstitial space, and so do a whole suite of other species that are grassland or savanna obligates. They need this type of structure that's created by having the clump grasses and the native forbs that are self-pruning. And that's providing a lot of things. One, this provides really great cover for several different things, such as nesting or just overhead cover from predators. A lot of the predators of these species are avian in these systems. And the forbs really provide a lot of benefit in that they provide some overhead cover, but they also provide a lot of high quality fruits and seeds, and also higher insect production in general than the grasses. So some herbivores, especially grazers, will use the grass for food, but in particular, most of the other species associated with this system are getting a large portion of their food from the forbs that are in this system. So you remember I talked about in the wetlands lecture, or if you haven't watched it, you'll see what I'm talking about. We're targeting annual grasses in wetlands. Now that's distinctly different from what we would target in an upland, savanna, or grassland. Okay, we in an upland, grassland, or savanna, we would be trying to promote annual forbs, so annual broadleaf plants. In the bottomlands and moist soil wetlands, we would be trying to promote annual grasses. And it's because we have very different objectives, right? Most of the things that we're targeting in terms of wildlife species that are using the wetlands are using them to get high quality seeds that are produced by grasses. In the uplands, a lot of the wildlife that are using that community are getting a lot of their food from broadleaf annuals, so those forbs in the system. But you remember, I wanted you to remember in that lecture, I talked about how we might get to that, and I wanted to give you some context of why disking and burning works like it does in the system, and also herbivory. So that what I'm showing you here is annual wheat, and you can see it's just, well, you can't see, but it's a seed right there. We plant annual wheat versus perennial wheatgrass. These are very similar taxonomically to one another, but one's annual and one's perennial. And you can see the root structure on the perennial is enormous in comparison to the annual. So basically, the annual plant is going from seed to growing a plant, flowering, producing new seeds, and then dying in one season. A perennial plant is investing its resources very differently. So it's playing the long game in this system. In other words, it germinates from seed, and then it invests a ton of time and energy into producing a root system that can help it persist for years and years. And generally, it may take multiple years even for it to get to reproductive maturity. Think about a tree, for instance. It takes a long time generally for a lot of tree species to produce, to be able to produce flowers. So, uh, this is kind of the strategy that the root system can help the plant stabilize and start gathering resources, and then it generally doesn't put that much effort into seed production in any given year compared to the annual that only has one season to produce all its seeds. So that's why we would target those plants, the annuals, because they produce so much seed relative to the other. But there's another important thing for you to realize related to these strategies. So this is kind of a cross section of a lot of the native plants that would be in prairie. A lot of the same ones would be in savannah. And one thing that I hope is immediately apparent to you is that they have enormous root systems. Okay, so in comparison to some of our non-native grasses that are improved pasture where we would do grazing, we bring in grasses. Notice this is an example of one. They have a really small root system comparatively, okay? So there's a couple of important things. One, that's an adaptation of the plant to being in a dry area. It tends to be really dry, especially in grasslands, but also in savanna, like the southeastern coastal plain. It rains a lot, but the soils are sandy and porous, and dries out really quickly. And we do have extended droughts, especially during the late summer. So one adaptation of this root is to get down to the water table so that it can withstand drought. And with drought and lightning striking a lot, you might imagine that a fire happens quite frequently. And in this system, these plants are very well adapted to deal with being top killed by fire repeatedly on a fast cycle. Remember, this is a less than 2-year cycle in much of Florida. So these plants, the root systems are protected and they can regenerate from fire. When they do that, they're actually really vulnerable to herbivores. And what we see is called this magnet effect, where you have fire, you have a drought, lightning strikes, causes fire, fire happens, and the plants respond to that by greening up and putting a lot of energy into growth, and they're really nutritionally valuable. And then the herbivory follows that disturbance and to take advantage of that resource. So the plants then have to deal with herbivory after they're regrowing from being disturbed by fire, and that's often during drought conditions. So you can imagine how much stress that is. So they produce these huge root systems like this in this system. uh, so what I was just talking about with the herbivore, so we talked about fire being really important for the distribution of the savanna, but something else that's been pretty evident from research, especially in African savannas where we still have a lot of the megafauna, is that when you exclude herbivores from the system, even if fire is still in the system, the savanna, so this is outside means that there are herbivores, inside means there are no herbivores, no mega herbivores. Fire is happening on both sides. Without the herbivore, even with fire, the plant community still succeeds into a forest system, even though you still have fire, the herbivore is critical to maintaining that kind of structure. So, what about in the southeastern United States or in that whole eastern range? So, I found this map, which I thought was pretty awesome, and I didn't realize how cool it was until I really started looking at it closely. And this was the basically showing the southeastern limit of the range of bison. And I had no idea, honestly. I tried to map that out. I missed a couple of the points down here in Florida. I should probably correct that. But you can see this was at least upon the time, in the 1800s when this was drawn, uh, with some of, they drew it based on historical accounts of people killing bison when they were settling or naming. A lot of places got named based on where they found bison. We found artifacts, all sorts of things. But this gives you a really good idea. Florida used to have bison in it, and it wasn't that long ago. It's pretty crazy to think about. In fact, over the course of just a couple of hundred years, bison ranged from down here to all the way almost extinct, but completely relegated to the Great Plains out in the Midwest. So pretty incredible how quickly uh, that range contracted when people settled, or the Europeans settled the land. So uh, we had the mega herbivore in the not so distant past to cause this savannah. So we know that fire is important, probably a herbivory as well, but one thing that I think is particularly important and definitely relevant to this lecture is to think about another disturbance that was key from that herbivore. So if you looked at a bison hoof, it has this really sharp angle right now. So think about it this way. Not only do we have fire occurring, and I wanted to show you this distribution right here is when lightning driven fire occurs. Notice that that's in June and July, right in the middle of the summer, right during that droughty time of the year. We have a lot of fire being created by lightning, or the majority of it. Then we have this herbivore that's coming in and eating all those plants that are regenerating, eating all that grass, and it weighs a ton and it's running around on 4 shovels. Okay, so think about that for a minute. We basically have this system where the herbivore is coming in right after fire and eating grass specifically, turning that into nutrients that are coming out the other end, which it is also disking in with, or shoveling in with its 4 hooves. And think about that there might be hundreds or thousands of these individuals in single single herds. I keep saying flock for some reason. So single herds running around after fire, and every time a fire happens, they all come in to eat there, and that soil disturbance is having this big impact. Now, let's think back to this strategy that all these plants have in here, right? So we not only have these grasses that are regenerating from fire and then being eaten by the herbivore, but when it's doing it, it's basically shoveling through the root systems, right? So all that trampling basically breaks up the root system on these plants. And because they've invested so much of their energy into developing that root system, they don't recover from that very well, at least not relative to annual plants. So one of the problems that I get asked about all the time from people who are managing savanna or grassland ecosystems is, how do I get more forbs in the system, right? We're using fire really commonly to manage these systems. We might come into this plant community and continuously burn it every 3 or 4 years. Grasses, especially perennial grasses, are really well adapted to deal with fire, and they can gain dominance in that system. So what happens when we repeatedly burn a grassland or savanna system is that we end up with this dominance of grasses. And you know, it's kind of one of those things where there's too much of a good thing. We want the native warm season grasses in the system. They're critical from a wildlife habitat standpoint. But when 95% of the plant cover is grass, that becomes a problem for wildlife. It's the same thing with water. You know, that's an essential part of our life. But if I drop you in the middle of the ocean, it will kill you, right? So it's too much of a good thing. And really, I think there's a lot of evidence to suggest that that's becoming a problem because we're using fire, but we don't have that mega herbivore stimulation of or that mega herbivore disturbance that's following fire that is really important for forbs, especially annual forbs, to colonize. So here's our bison right here, and this is a disc behind it. So a plow or a disc can be dragged behind a tractor, but essentially, if you have a grassland, you can go into that grassland when you have that problem of too much grass and disc, and that's sort of mimicking the disturbance from the herbivore or that hoof action, right? That's happening from the bison. And what happens, like right here, you can see where we've disc, we had dominance of grass, and then we shifted that dominance toward herbaceous annual forbs. Okay, they colonize that really well. And a lot of the forbs are annuals, and they're seed bank builders, and they're sitting in the seed bank waiting on that soil disturbance. A lot of them are light activated, actually. So you break up the soil and the seed gets exposed to that new photic uh, condition, and it stimulates it to germinate. Not all of them, but a lot of them do. So that hoof action, or in this case, using the disc to cut off that, really shifts dominance and competitiveness from the perennials toward annuals that are sitting there waiting to colonize that disturbed area and putting a lot of effort into that. So if you repeatedly burn an area like this, you're going to end up with a lot of grass, and without having some soil disturbance, uh, you know, you won't get that forward component, which is so critical for wildlife habitat. So let's think about the timing of that really quick. So I just showed you when fire happened naturally was during the summer. And then you think about for the next several weeks, you have herbivores running around. Another thing that happened pretty commonly is what's called a grazing lawn. And the grazing lawn hypothesis is essentially this idea that, you know, you have fire happen that initiates this positive feedback where the herbivore comes in and continually keeps munching down the grass that's resprouting from it. And as it does that, the plant then puts more energy into growing, is more nutritious, which is more attractive to the herbivore, and you end up with this cycle. And sometimes that cycle will last all the way into the dormant season. So think about that for a minute. We've got fire happening in July. Herbivores immediately come in, continually grazing that. You have this grazing lawn that perpetually attracts the herbivore back into it. Lots of hoof action happening, and it's all happening from, you know, August through winter. Okay, so that's pretty important from a timing standpoint. So here's an example where we have our bison that we're dragging through here in this grassland right after it was burned. And notice that it's dormant season, the trees don't have any leaves. So this is November or December. And then if we look at that, you can see this different color in the stripe right here. That's all native forbs coming up in it. Okay, so there's a reason why that happens. Most of our native forb plants and our native grasses also have hard seeds. Well, particularly the forbs. They have what's called a hard seed, and they can sit in the soil through the winter really easily and wait to germinate during the spring. A lot of our non-native plant species have a soft seed strategy, and what happens is if you disc to stimulate that germination and they have to sit there through the dormant season, our native plants do that really well. Our non-native invasive plants don't do that very well. So if we disc during the fall or winter, which is coinciding with when that bison hoof activity would have happened, we end up with native plants responding to that disturbance. Whereas if we disc during the spring or summer, when the plants can immediately germinate, it's already growing season, we normally end up with invasive plant species colonizing. So let me show you some data. One, disking is used really well to reduce grass density, right? That's what we're talking about. We're trying to meet a balance between the perennial native warm season grasses and the annual forbs in this system. So if we do nothing, you can see that's what I'm talking about. We're getting up in the 90% grass coverage range. Warm season grasses, that's what that means. Native warm season grasses is what that acronym means. So if you burn during the dormant season like we do so often, that doesn't change the density. If you bush hog, so go in and just mow it down, that doesn't change the density. Using herbicides can be effective, but not very effective when you compare it to disking. It doesn't matter if you disc in the fall or the spring, we're going to decrease the native warm season grass density. The difference is with that timing is when you disc during the fall, a much higher proportion of the plants that colonize that are desirable forb species. Okay, so you can see that not very much of it is undesirable. However, when you have that spring disking, and if you move this around, this was done like during March. If you move that around to May or June, probably that red goes down even into this range. So even more so problematic when you do it a little later in the season. But the general idea is that, you know, historically that's the way the disturbances work, and we're trying to mimic that disturbance regime when we're managing these systems. So here's just giving you an example. When we disc the same field during December, this is all common ragweed, and you can see a few grasses poking up right here, but a whole bunch of forbs in that system. And this one, you get some of those same forbs. This is common ragweed on both sides, but notice that's in April. A lot of the plants like this one right here, this is called Johnson grass. It's a non-native invasive plant that's problematic in this system, can colonize that area and generally end up dominating much more of it. So the take-home message of that is if you disc sometime between October and February, you decrease the dominance of native warm season grasses, and you generally enhance wildlife habitat for almost all of the species associated with the system. Also, if you disc at the right time like that, it decreases the need for other strategies like using herbicides to control weeds. All right, so here's another example of the before after. You can see how dramatic that effect is on the plant community. There's all kinds of ways that we might do this to try to enhance the structure of the cover in it to make it more diverse, right? It's not generally advised to have these little short linear uh, uh, bouts of plant communities like this, these edges. So trying to diversify that is pretty effective. Another thing is when you disc, that makes it vulnerable to erosion for a little while, especially if you're doing it during the wet part of the year. And because of that, we might want to have, you know, especially in places where we have slopes, we might want to follow the slope or the contour. But there's a lot of different ways, a lot of great strategies for using this to maximize the benefits while also minimizing the negative effects that can come with it. So let's go back to wetlands for just a minute. Remember, we're targeting grasses in this. Not always are the grasses the only beneficial. Like for instance, we have smartweed right here. That's really beneficial to waterfowl as well. But notice all these grasses right here. This is a Cloa. It's called barnyard grass or wild millets. Panic grasses, you can just see how much seed is produced in that. Here are some of the undesirable plants, particularly sicklepod and cocklebur are really problematic, and they don't produce much food if they produce any. Actually, sickle pod's toxic, and cocklebur, virtually no wildlife species will eat it. There is a little bit of structural benefits to having Sesbania, but the main thing that you need to know is that disking in this system can be really effective because of the same reasons we just talked about to manage for these annual grasses. Remember, we want annual grasses in the wetland system because of the seed production, whereas we want the fruit and seed and insect production in the uplands, which typically is more associated with our annual forbs or annual broadleaf plants. So you normally don't want to disc the entire area, but you might have it on a rotation so that you can continually make sure that you set the plant community back to annuals. We're bringing down the water, remember, during the summer, we let it dry out, and then you have disking on part of it. And what that does is create this system where you have sort of a Hemingmarsh concept where we have some structure that's really good for loafing and cover, and then we have some open water that's really good for foraging and multiple age classes of plants within that. That's really valuable for waterfowl, and you can see a lot of them are foraging out in that, and then they can use some of this other uh, vegetation that has emerged from the surface as cover. So in general, when we're disking these systems, this is an exception. Again, in the wetland system, we're disking during the early summer once it gets dry enough, which remember is different from what we would do in the uplands. Also, it's pretty common practice after we disc to go in and mow it. And this is about the only time we would want to use mowing for wildlife management, is when we're knocking down a lot of these plants to make seeds available for the waterfowl that are going to colonize it once we flood it. Okay. So don't mow in uplands because it tends to promote mat forming species, and that structure that we're looking for with the interstitial space is lost pretty quickly when you're using mowing to do it. Fire and disking are preferable in the uplands. So just before we'd flood it, we go in and knock down some of the vegetation, and that allows that open water for foraging habitat. And also a lot of the duff produces uh, invertebrates, which are eaten by a lot of the species. So hopefully you enjoyed this. I know it was a little bit longer than usual, but I appreciate you taking the time to listen to it, and I hope you enjoyed it. I definitely enjoyed putting it together, and I look forward to talking to you all and discussing this week about this stuff.